Hi and very good evening. My name is Amir Safwan Shah bin Shahrudisa. My meeting number is B132510 301, and today I will explain about objective in this slide. So the first objective is to design scissor gadget using SolidWorks CAD software. This allows us to create an accurate three-dimensional model project of the model of the jet and its component. The second objective is to evaluate the structural performance of the scissor jack when a load of 5,000 Newton is applied. The analysis will focus on the stress, deformation, and safety factor of the design. Lastly, this project aims to identify any weak areas in the structure and make suitable improvement to increase the safety and reliability of the scissor gadget.
Hi, my name is Pavitra Malni Anak Perempuan Rajamurti and my matrix number is B1325103005. I will be continuing the presentation from here. So next, as we can see here, we have the model assembly. The software that we used is SolidWorks simulation and the method is the finite element analysis, also known as FEA. So for this model, the car jack that we have assembled, we applied a load of 5,000 Newton. For the material selection, we've done some research and the material that we decided to use for all components are AISI 1020 steel. As we can see here, the elements include carrier member, base plate, connecting pin, washer, lifting saddle, pins, base pivot, bracket, upper arm, lower arm, bracket pin, and power screw. So all of these materials have been applied with AISI 1020 steel.
Hi, Assalamualaikum. My name is Muhammad Rashidul Amin bin Bahtiar and my matrix number is B1325102997. Now, I will present the simulation result of our scissor car jack. The simulation was carried out using SolidWorks simulation with an applied data load of 5,000 newtons. So the slide is there are three important results from the simulation: von Mises stress, displacement, and factor of safety. First is the von Mises stress. The maximum stress record is 634.3 megapascal. The highest stress is concentrated at the upper joint of the scissor jack. This value is higher than the yield strength of the IC 1020 steel used in our design. This means the material may start to deform permanently when subject to the 5,000 Newton load. So the next one is displacement. The maximum displacement is only 0.55 millimeter. This shows that the overall deformation of the jack is quite small. So the structure is still relatively stiff. However, although the displacement is low, the stress is too high. Therefore, the main problem is material failure due to excessive stress and not excessive deformation. Lastly, the factor of safety. The simulation give a factor of safety of 0.55. Normally, a safe design should have a factor of safety greater than 1, and most engineering designs aim for around 1.5 to 2 or higher. Since our FOS or factor of safety is below 1, this indicates that the current design is not safe to support the applied load and improvement are required. Thank you.
Hello, my name is Mama Amar Ben Azmi and my matrix number is B12325102888. And I will be explain design improvement. The first one, structural improvement. Increase carrier thickness 2mm to 4mm. Material upgrade. Replace IC 1020 steel to IC 4130 alloy steel. An additional improvement, anti-slip base texture and optimized screw thread pitch.
Hi, my name is Safia Masara. My matrix number is B1325109797. So So the conclusion part is, we successfully designed and analyzed our scissor jack in SolidWorks. However, the design fell under a 5000 Newton load because of high stress concentration. To fix this and make it safe, we need to upgrade the materials and modify the structure.